Hello, Algebra 2. We are in the final section of this class. Um, Chapter 6, Section 7, Solving Logarithmic and Exponential Equations. Essentially just solving equations using the properties that we learned with logarithms and exponents. Um, let me... Oh, I am zoomed in, okay. So essentially at the top here of these notes is just a recap of all the properties we've learned. Definition of log, how you can go between an exponential form and a logarithmic form. You can go either way here. You can go, sometimes you're given exponential forms, and if your unknown is in the exponent in particular, then you want to change it to a logarithmic form. If you are given a log and your unknown is either in the base or the value, then you want to change it to exponent often, and that's how you can solve those. Then we did the product property. When you have a product inside a log, that can be written as two logs with a plus between them. Be very careful with this. Many people are still making the error where they don't put the second log here. It goes from one log to two logs. One log to two logs with a plus in between. If there's a plus, there needs to be two logs. If there's a times, then they're together in one log. Same with the quotient one, it's just the plus changes to a minus when there's a division in the log. You cannot add these logs together. You can't add m and n together. That doesn't work in logarithms. You can multiply m and n, like right here. That's okay to do because they're both inside the quotient, the parentheses. But often they'll be giving you something that you can't actually multiply together, like 2x, or maybe they just want you to write in as many logs as possible. But be careful with that property. There's still a lot of, and this goes either way too, but there's still a lot of people making mistakes here where, I don't know, they change this and then they add these two together. But you could go this way where you have two logs and you want to condense it to one log. Well, there's a plus between those two logs. You're taking m times n and write that as one log. Same with this. If you have a minus, you can condense that to one log. Of course, all of these have to have the same base or everything's out the window. The power property was where you can take something that's to m to the power of p. In this case, you can write that down in front. I'm not going to go through how these all work anymore. Again, you can go back to those videos in the past and see how that the details of how that works. So whenever you have a power inside a log, you can write that in front with a times. Multiply goes out in front of the log, and you can multiply it. The inverse properties. This is where when you have the base of something to the power of the same base. Well, sorry, let me start over. When you have something to the power of log base, then it's the same bases here. Those actually kind of cancel each other out. And whatever's here is the answer. Same here, if you have log base b and then to the power of b and to the x, those cancel each other out and you just have what's here. You could use the power rule here to bring the x out in front. Then you have log base b, so you have x times log base b of b. Well, b to what power gives you b? Well, it'll be 1, so x times 1 is x. One-to-one properties. This is where you want to, if you can, and sometimes this works, sometimes it doesn't. If you can get the same base on both sides by manipulating or working with what's on one of those sides, once you have the exact same bases, you can set the exponents equal to each other. I think we're going to do a few like that. So once the exponents are equal to each other, then you can solve this like a normal equation. Same with logarithms. If you can get it down to one log on each side, log base b on each side, you can set the things equal to each other, the stuff inside of it. Essentially, they're canceling each other out. Kind of. It's not dividing, but you can think of it that way. And the last of this list of properties is the change of base formula. Log base b of a can be changed to any log base, and often we do this to change it to log base 10, which is just the common log. So you could do log base b of a is equal to log a log b, and I'm leaving out a base, and that means it's base 10. So log a over log b. That makes it easier to type into the calculator. You can also do natural log ln of a over ln of b. It doesn't matter what this base is here, as long as the big number here, the big number, I mean the larger sized number, as in it's not subscripted, goes on top, and then the subscripted number goes on the bottom. That's how it has to go. So I'm going to do a couple of examples here, and then I'm actually going to do some book work for more examples, and then I'm going to assign some book work. And then that'll be due. So this is going out. This video is being recorded on the 17th, but going out on the 21st, and it'll be due the 27th. And then there will be a review packet due the last week. Might send that review packet out early, so that you have extra time to work on it. So that's that aside. Example 1: solve log, no base. That means base 10. Keep that in mind. X plus log x minus 3 equals 1. Okay, so if I want to solve this, I have this property that allows me to combine these two. We have two logs here. It'll be better to have this as one log. So I have a property that allows me to combine two logs separated by addition with the same base, obviously. It'll always be the same base, otherwise you can't do anything, you can't solve this. And that property, doing that property says that you need to multiply the things inside the log. So I'm going to multiply, right, this is one log, I'm going to have x times x minus 3. Well, x minus 3 is in parentheses, so it's going to be x times quantity x minus 3. You can distribute the x into the x minus 3 and get x squared minus 3x. And now I have one log with a base 10 to all this stuff, and then equal to a number. There's nothing else going on. It looks like this, right? Except, I mean, other than it's switched around. Log base something of x is equal to something. So since I have that, I can convert this to exponential form, which I'm thinking I'm going to want to do because my unknown is inside. If the unknown is not over here, if I have unknowns here or in the base, then I can't really do much. So I need to convert this to exponential form. Okay, if the unknown is in the power of an exponential form, then I have to convert it to log. But if I have a log and the unknown is in the log somewhere, then I have to convert it to exponential form. So I'm going to take this. The way we do this is base to the power of value is equal to what's inside the log. So x squared minus 3x is equal to base of 10, which I mentioned earlier, to the first power, or just 10. I'm going to subtract 10 from both sides, and I have x squared minus 3x minus 10 equals 0. Now I have a quadratic. We spent some time solving quadratics. So you factor two things that multiply to negative 2. Sorry, two things that multiply to negative 10 and add to negative 3. Okay, and then you set each of these equal to 0, but you'll never have a negative answer for these, by the way. Well, I shouldn't say never. You'll never have an answer that causes one of these logs to be negative. So I went through this quadratic part real quick because we did quadratics before. Two things that multiply to negative 10 and add to negative 3 are negative 5 and positive 2. Then you group those. I didn't do the whole box method. You can if you need to. You do not need to type up the box method. That's not possible. It's not very easy to do. Yeah, I kind of rushed through this, but you can revert back to your quadratic stuff if you're confused there. So I'm looking at these two answers, 5. I plug 5 and I have log 5, and then I have log 5 minus 3. That's 2. That's fine. But if I'm plugging negative 2 in, what I have here is log of negative 2, and I can never have a negative inside of a log. That's why I canceled out negative 2 as a solution. It's not always that it's a negative. It's just not always that just because it's negative we cancel it out. It's because if you plugged it in to the calculator, which I can load up my calculator here. If I plug it into the calculator, I'm going to block the problem a little here. You'll notice that if I plug, and I can just do the log because it's log base 10, so I can just do the common log button. Negative 2, you'll notice, bam, error. So that can't be a solution. Whereas 5 would be fine to plug into the calculator. No problem. I mean, it's an irrational number, but. All right, here's another example. Solve for e to the power of 3x minus 5 equals 72. All right, so first thing I want to do in this case is, so you notice how the unknown is in the exponent, but I cannot convert this to logarithmic form because it's not base to a power equals a number, because this 4 is out in front. It disrupts that. But we can easily get rid of that 4. Divide both sides by 4. And you get 18 on the other side. And now I have base to a power equals a number. And I can convert this to logarithmic form, or I could take the log of both sides. I'm going to do the natural log of both sides because the natural log is the same base as what I have here. Because I could choose whatever log I want to take to both sides. I could do log base 7 of both sides if I want, but it has to be the same log base, but I can do it to each side. Well, why not just choose the log that has the base that I have here? And that's what I'm doing. And actually, I can actually then, you can think of it as bringing this exponent, as messy as it is, out in front, and then ln of e is 1. The reason ln of e is 1 is because it's e to what power gives me e, because e is the base for an ln, and the answer is 1. And so what happens is I still have this ln of 18 though. That's going to stay there. It's not going anywhere. But this ln and this e cancel each other out, giving me just the exponent, or bring it down in front and then ln of e goes to 1, and you're going to end up with just the exponent. So this is the case where you want to take something that's an exponential form, get it to a form that you can convert it to logarithmic form, or take the ln of both sides. We wouldn't have wanted to take the ln of both sides before we canceled divided by 4 though, because that adds that in there, and then this doesn't just cancel out so easily. So always get it to exponential form. But if you're here, you're taking the ln of both sides, or you're converting this to exponential form, or from exponential form to logarithmic form, you should end up with the exponent equal to ln of 18, either way you do it. So at this point then, I'm solving this for x. ln of 18 is just a number. So I'm going to put it in here. I don't want to see, no problem. It's a number, it's a messy number, but I'm going to leave it as ln of 18 for now, but I just wanted to show you that I can treat this like any other number. So I can add 5 to it, that's no problem. I can then divide by 3, and I get this ln of 18 plus 5 equals 3, which is a messy number, but it is just a number. You could actually, if it's easier for you, go ahead and convert this to a decimal up here. Then you'll have this plus 5, and then you'll have 7.89 here, or no, here. Change it to an approximately equal to, of course. And then you're going to divide both sides by 3, and you'll get 2.63. Okay, so I'm going to jump over here and show some problems from the, just to give you some more examples to look at. I'm going to show you some problems from the book, and then I'm going to assign some problems from the book. So these are some problems I did a long time ago, but I think they'll hold up here. So number 9, they're just going to asking to solve for x for all of these. So here's a situation where we were given 3 to the power of 2x equals 81. One way to solve this would be to get like bases on each side and then set the exponents equal to each other. We want the bases to be exactly the same, and we can't just do anything we want. We have to do something that's equivalent. So 81 is equal to 3 to the power of 4. 3 times 3 times 3 times 3 is 81. And I can change 81 to 3 to the power of 4, and then because I have a base of 3 and a base of 3, nothing else anywhere around except stuff in the exponents, I can set the two exponents equal and then divide by 2. But if you're not seeing that or not comfortable with that, you can always take this, which is already an exponential form, it's standard exponential form. There's nothing out in front. There's no addition or subtraction floating around. It's just a base to an exponent. However messy the exponent is, that's fine. It's just that there's no mess outside the base and the value over here. So I have a base to the power of 2x. So that's my exponent is equal to 18. I can convert this to logarithmic form and do the exponent of 2x is equal to log base 3 of 81. And log base 3 of 81, if you have to put it in your calculator, if you have this ability down here to do the base, you do that. Or if you don't, you could always do, remember, you could just do the convert rule, which would be you can use any log 81, any log, common log I'm going to use, and then log 3. Oops, I need to put the 3 in. You get 4 either way. And then I have the 2x equals 4, and then that's just dividing by 2. I don't know if I'm going to do all of these problems, but I'm going to do a few here. Solve log base 3 of 1 over 24. Sorry, let me just bring up these problems real quick, just to make sure that I'm not doing anything wrong. It says solve each equation for x, and we're looking at 11. Write the solution with nearest hundredth. So they're asking for 2 decimal places, by the way, if it's not exact. All right, so this one's actually solved for x already. I mean, they already have x equals. They give it to you as x equals. And so x equals log base 3 of 1 over 27. Well, if you put that in your calculator, you're going to get negative 3. But to do this, one way to do this would be to convert the 27 into exponential form. And then change that to the same base as this. This is a little bit more of a complicated way to do it. This is pretty straightforward because you're able to use that function in your calculator. I would say don't do it the way I did it here. Instead, do log log base of 3 of 120 over 27, and that's straightforward. Again, I didn't redo these. What's going on? There we go. Negative 3. But if you don't have that ability, you could always do common log of both sides. So log of 1 over 27, that fraction is the normal scripted number over common log of 3. That's the subscripted base. You get negative 3 either way. Okay, so here's one that, let me just work my way through this. 13 log base x. So the unknown is in the base, and this is definitely one where we want to convert to exponential form once we get it in standard logarithmic form, which it is. It ends up being in standard logarithmic form. So log base x of 1/16 is equal to negative 2. Converting this to logarithmic form, from logarithmic, sorry, to exponential form would be x to the power of negative 2 equals 1/16. We want to solve this. Solving for something to the negative 2. You cannot take the negative 2 square root. It's just not something that exists, and it's not something that's common, so I don't accept it. I ask you to rewrite it. But you can get rid of the negative in the exponent by taking this and putting it under a 1. So 1 over x squared, okay? 1 over x squared equals 1 over 16. Well, that means you could cross multiply here and get x squared times 1 is equal to 1 times 16. X squared is equal to 16. Or you could think to yourself, well, if it's 1 over equals 1 over, then you can just set the denominators equal, because everything else in the equation is equal. So then I have x squared equals 16. The square root of 16 is 4. Negative 4 is not a solution because you cannot have a negative in a base here. You can't have a negative here, and you can't have a negative here. Let's do one more here. This is e to the power of 2x is equal to 20. This is a base to power equals a number. You can convert this to logarithmic form or take the ln of both sides, either way. And I'm using ln because this is base e. If it was a base 2, I could just do 2, log base 2, log base 2. If it was a 10, I could do common log. Either way, this ln and this e will cancel out and leave you just the 2x, ln of 20. I'm going to divide both sides by 2. You can convert ln of 20 to a number before you divide by 2 if that's easier for you. Either way, you should get ln of 20, which actually, let me show you what that decimal value is. So that would have been, if you convert it to a decimal right away, 2.998. We're dividing that by 2 and getting the 1.4. Let me do one more after this one because I'm kind of on a roll and I'm having fun. Okay. 17 here. Okay, so ln of this stuff equals ln of this, so 2x minus 3. Since there's an ln on both sides and not just one side, that's different than if there was an ln on just one side. I don't want to convert this to logarithmic form, from logarithmic form to exponential form because there's an ln on both sides. You have to put an ln in the exponent, so you don't get rid of both ln's. But because there's nothing outside the ln's, we can actually just drop the ln's. It's an ln of something equals ln of something. You can set the somethings equal to each other. And then solve this for x. That was easy enough. Add 3 divided by 2. Okay, I'm going to keep going, apparently, because this is just so much fun. 10 to the power of 2x plus 75 is equal to 150. So here's an example of an exponential form. There's no logs, right? That's not in standard form because it's not base to a power equals something. You have this plus 75 in here. Okay, I got to get rid of this plus 75 before I can say convert this to logarithmic form or take the ln of both sides, or take an exponent of both, or take a log of both sides. But I can do that pretty easily by subtracting 75 from both sides. Okay, so 10 to the power of 2x is equal to 7, because 150 minus 75 is 75, by the way. Don't get confused by that. It's just that this happens to be the same as what you get when you subtract from this. Now I can take the log of both sides, or I can just convert directly into a logarithmic form. Either way is fine. So base to a power is equal to a number. So so when we convert that to logarithmic form, you get the exponent, 2x, is equal to the log base 10, which we can just write as log because it's the common log, equal to the value of 75. Now common log of 75 is a decimal, and if you want to convert that, go ahead to a decimal value, 1.875, and then you're going to want to divide that by 2 to solve for x. So 0.938. They only ask for 2 decimal places, but I like 3 decimal places. Okay. So here's another one, 21. Like, I thought I was going to quit, but I guess I'll just go through all of these and assign the evens. These are all the odds, and I'll assign all the evens. So 21, because this is a good example to show too, where this is not logarithmic form, there's logs all over the place. I want to get this down into, and by the way, this is ln, this is ln, this is ln. I don't know why I didn't do my cursive LNs back then, but I didn't. But so this is 3 times ln of x. You'll be able to see this is what's given. 21. 3 ln of x equals 3 ln of x equals ln of 4 plus ln of 2. So I can't cancel out the ln's. I could cancel out 2 ln's if they were both the only thing on each side of the equation. Like, I could cancel them out on each side, like we did right here. But notice how we have pluses, and it's not just one ln, it's just all sorts of stuff going on. But there's 2 properties going to help us here. First, the exponent property. I can take this, that power property where I could have the power and I can bring it down in front, goes the other way. I can take this and make it an exponent. So I could change this to ln of x cubed. And then the addition, the product property, I have 2 logs separated by a plus. I can make that 1 log and multiply the stuff inside. So 4 times 2. So ln of 4 plus ln of 2 is equal to ln of 8. Okay, ln of 4 plus ln of 2 is that decimal value, the same thing as ln of 8. See how they're equivalent? So then I have ln of x to the cubed, or x cubed, like I had mentioned about taking that power, moving it up, and ln of 8 using the product property. Now I just have an ln equals stuff ln of stuff equals ln of stuff, and I can just set this stuff equal to each other. Take the cube root of both sides, or think what cubed is equal to 8, and the answer is 2. Okay. In 23, so we have 2 times ln of x plus 2 equals 1. I only have 1 ln, okay, so I can't use any of the properties I used up here. Well, no, I'm sorry, I can't use this property that I used up here. I still want to use the property where I take this and move it as a power. And then I'm also going to just simplify this stuff that's also outside the ln. And so I get 2, okay, so I'm subtracting 2 from both sides again, negative 1. And then I'm taking, oh, okay, sorry. There's a couple ways you could do this. Okay, over here I did it that way. So I made it the power of x squared. And here I divided both sides by 2. Let me just show the answer for both sides here because they're not really lined up correctly. So then I divided by 2 and I get negative 1/2. And then I'm converting ln of x equals negative 1/2 to exponential form. So base e, okay, x is going to be equal to base e to the power of negative 1/2. And e to the power of negative 1/2 is that decimal. What did I do wrong there? Oh, I didn't do E. I did ln. So that's the decimal 607. The other thing that I was thinking of doing was taking it, making it a power, taking this 2 and making it a power of x, and then converting this to exponential form. So I have e to the power of -1 equals e squared, okay? Or e squared is equal to e to the power of -1. And then I would take the square root of e to the -1. So in this one, let me move this over. I know it'll be blocked by my little screen, but you don't really need to see my buttons being pushed. I don't think. Or should I turn the screen off? Maybe I'll just turn my... oops, that's the wrong one. That's the one I want off. Okay, so in this one, I would take e to the power of -1, get that decimal value, and then take the square root of that answer. And you can see how you get the same thing either way. Yeah, so either what method works. I think there's one more, and then we're done, and I did all of the odds in this bookwork that you will have the evens to do. So 3 times log base 10 of x plus 7 equals 5. Again, 1 log. It's not in standard form. I need to have a log equals a number. Log base something equals a number. So I'm going to subtract 2 from both sides. Divide both sides by 3. I get -2/3. Convert this to from logarithmic form to exponential form. And you have x, the value here, is equal to base to this power, and just type that in to your calculator, and you get 10 raised to the power of -2/3. Oops, no need for an x paren there because this isn't free math app, and you get that value there. All right, so I went through a whole bunch of examples here of solving logarithmic problems, so hopefully that helps with the homework, which will be the evens. So I went through all the odds actually in this problem set here, and then I will assign the evens. Maybe all of them. I don't know yet. Probably all of them. So yeah. So okay. So hopefully that makes sense. Let me know if you have any questions. Thank you and good day.